Welcome to the DIY Honda Garage channel. In this guide, we will address the diagnostic trouble code DTC P1659, which indicates an ETCS, Electronic Throttle Control System, control relay off malfunction in the Honda CRV models from 2017 to 2022. The ETCS is a vital component that manages the throttle's position to ensure optimal engine performance and efficiency. This malfunction can lead to drivability issues or reduced engine responsiveness, necessitating thorough troubleshooting. We will systematically examine the potential causes, symptoms, and steps for effective diagnosis and repair. Ensuring a proper understanding of the electronic systems involved is crucial, as they directly impact vehicle safety and performance. The DTC P1659 indicates a malfunction in the ETCS control relay, which plays a crucial role in controlling the electronic throttle of the Honda CRV. The ETCS controls how the throttle opens and closes based on driver input and engine conditions, thereby ensuring proper airflow into the engine for optimal performance. The relay that governs this system can be found in the underhood fuse relay box, where it interfaces with the powertrain control module PCM and various sensors. When this relay fails to operate correctly, it can create issues such as erratic throttle response or limited engine performance. The loss of throttle control can not only affect fuel efficiency, but also compromise vehicle safety, emphasizing the need for prompt diagnosis and repair. Several issues could contribute to DTC P1659. A primary suspect is a faulty relay circuit board, which may fail to engage the throttle control as intended. This board acts as a central hub for the relay system. If it malfunctions, the entire ETCS can be adversely affected. Another common cause is a blown fuse, specifically fuse number 8815A, located in the underhood fuse relay box. This fuse is responsible for providing power to the relay and, when blown, can prevent proper operation. Lastly, open or shorted wires within the circuit can disrupt communication between the relay, PCM, and throttle control, further complicating performance and response issues. Identifying these causes accurately is the first step toward effective repairs. The symptoms associated with DTC P1659 can vary, but often include erratic throttle response, which may feel like the vehicle is hesitating when accelerating. This can manifest as a lack of power or sluggishness, making driving experience frustrating and potentially dangerous. Additionally, there may be a notable decrease in overall engine performance. The engine may run rough or stall unexpectedly under certain conditions. The check engine light on the dashboard is another telltale sign that indicates the need for immediate diagnostics. Monitoring these symptoms closely can facilitate a quicker identification of the underlying issues, ensuring a more efficient troubleshooting process. The first troubleshooting step for DTC P1659 involves verifying the problem conditions. Begin by turning the vehicle to the on mode, which activates the electronic systems for diagnostics. Use the HDS, Honda Diagnostic System, to clear the DTC from memory. After clearing, check for any pending or confirmed DTCs that may appear. If DTC P1659 is still indicated, you can assume that the failure has duplicated, warranting further investigation into its underlying causes. On the other hand, if it does not show up, the issue may be intermittent, suggesting the system is functioning as expected at this time. In such cases, inspect for poor connections or loose terminals, especially around the relay circuit board and PCM, to preemptively address potential intermittent failures. For the second troubleshooting step, you will need to remove the relay circuit board for testing purposes. This circuit board is critical to the functioning of the ETCS, and any faults here could directly lead to the DTC P1659. After removal, test the circuit board to determine if it operates as intended. If the relay circuit board tests as functional or okay, move on to the next troubleshooting step. However, if it's determined to be faulty, the board must be replaced before any further checks can be performed. Ensuring that the relay circuit board is operational is essential, as it functions as the controlling device that connects the throttle system to the PCM. Step 3 requires turning the vehicle to the off lock mode. Once in this state, focus on inspecting fuse number A8, which is crucial as it is responsible for the power supply to the relay circuit. Find the fuse located in the underhood fuse/relay box and examine its condition. If the fuse is intact and passes the visual inspection, you can proceed to the next troubleshooting step. Conversely, if the fuse is found to be blown, this indicates a problem within the circuit, requiring further action to investigate and rectify the underlying cause. This step is vital as it determines whether the electrical circuit supplying the relay is intact. In this step, you will perform an open wire check on the +B FI subline. Measure the voltage between two test points. Ensure the vehicle is in the off lock mode and that you have removed the relay circuit board. The first test point is located at the relay circuit board connector, specifically at pin number 14, while the second test point is the body ground. A successful test should return battery voltage, confirming that the +B FI subwire is functioning properly. If battery voltage is present, you can confidently proceed to the next troubleshooting step. However, if there is no voltage, this suggests an open condition within the wire, indicating that repair is needed between the number A8 fuse and the relay circuit board. The fifth troubleshooting step involves checking the continuity of the FI sub-RLY outline. Begin by jumping the SCS service check signal line using the HDS, and then wait for more than a minute to complete this process. Once this initial setup is complete, disconnect the PCM, Powertrain Control Module, Connector A. With both the relay circuit board removed and the PCM connector disconnected, you can now evaluate continuity between the relay circuit board connector at pin number 1 and the PCM connector at pin number 16. If continuity is confirmed, it indicates that the wire is intact and you can proceed to step 6. However, if there is no continuity, an open wire exists and should be repaired to restore proper function. This step focuses on checking the continuity for the FI sub-RLY CL line. Begin by ensuring that the vehicle is in the off lock mode and that both the relay circuit board and PCM connector A are disconnected. Conduct a continuity test between the relay circuit board connector at pin number 3 and the PCM connector at pin number 25. If continuity is confirmed, this suggests that the FI sub-RLY wire is in good condition, meaning it does not need immediate replacement. However, if there is no continuity, it indicates an open circuit that must be repaired between the PCM and the relay circuit board. Following prescribed service information can be useful here, as authorized updates may provide additional guidance on further diagnostics related to this DTC. In step 7, the focus shifts toward determining if there's a shorted wire within the FI sub-RLY outline. You will begin by jumping the SCS line with the HDS, allowing ample time to elapse, over 1 minute. Disconnect the PCM connector A prior to executing the continuity test. Measure continuity between PCM connector pin number 16 and the body ground. If there is continuity, this confirms the wire is shorted, necessitating repair to eliminate the short condition, alongside replacing fuse number A8, 15A in the underhood fuse relay box. If there's no continuity, it suggests that the wire is intact, allowing you to proceed to the next step to ensure all potential issues are investigated and resolved. The final troubleshooting step evaluates the +B FI subline to ensure it is free of shorts. Again, the vehicle must be in the off, lock mode, and it is essential that the relay circuit board is removed prior to testing. Check for continuity between the relay circuit board connector at pin number 14 and the body ground. If continuity is confirmed, it suggests that the +B FI subwire is functioning as intended. However, if continuity is absent, this indicates there is a short somewhere between fuse number A8 and the relay circuit board, which will require repair. It is also advisable to check authorized service information or substitute with a known good PCM, which may offer further clues to the troubleshooting process. After completing all necessary repairs based on the previous steps, it is essential to verify that the work completed is effective and that the issue is resolved. Start by clearing all DTCs using the HDS to refresh the system. Following this, take the vehicle for a test drive under various conditions to observe its performance. Monitor all relevant systems to ensure that no new DTCs emerge and that the throttle response behaves correctly. This step is crucial as it confirms the reliability of the repairs made. Documenting the test drive results can also provide insights for future reference, ensuring that all safety and performance standards are met. To prevent recurring issues related to DTC P1659, a routine preventive maintenance schedule should be implemented. Start by regularly inspecting fuses, particularly those associated with critical vehicle functions, to ensure they remain intact and functional. Additionally, check all electrical connections involved in the ETCS system to identify any signs of wear or corrosion, which may lead to malfunctions. Utilizing quality replacement parts is equally important. Substandard components can shorten the system's lifespan and lead to further repairs down the line. Implementing these practices not only maintains the performance, but also enhances the longevity and reliability of the vehicle's electrical systems. In conclusion, effective troubleshooting of DTC P1659 revolves around understanding the electronic throttle control system and its associated components. By meticulously following the prescribed troubleshooting steps, technicians can effectively isolate and resolve the issues causing the malfunction. Recognizing symptoms early is also vital for timely repair. It can mitigate potential safety risks and performance impairments. Additionally, implementing a regular maintenance routine is crucial to keep the ETCS and related systems functioning optimally. These practices not only ensure a reliable driving experience, but also help extend the operational lifespan of the vehicle. Please like and subscribe to the channel. See you next time.